Okay, I'm about to plug the printer in and I expect this BL touch to go up and down a couple of times. Which it does. The BL touch is powered off the same servo ports as the servo will be. That is off the 5-volt buck converter I've just fitted in. Now I'll just show you the LCD 12864. Might have to turn some of the LEDs off for this. Let's see. Sometimes get too much glare. So here's the LCD 12864, and if you go under prepare, we've got quite a few, but under here we've got BL touch self-test. I'm just going to move over to the BL touch, so when I press the button we can see what happens. So press the button there and you can see it goes through a routine of just going up and down all the time. So if the focus has gone out here, I can't handle the lighting, I don't think. Okay, so that's like a self-test. Turn this LED off. Now it's like done a timeout and it's gone back to the default screen. But if we look under control here, can you see this? We've got control, go under control, and we've got an option there, BL touch, and we've got quite a few settings. Reset the BL touch, another self-test option under here, deploy, which is like bring down the pin, and store, which is raise up the pin. So first of all I'm going to do reset. Let's hope it doesn't turn up thingy while I do this. So there we go, and it's reset. Now I'm going to do the self-test under the control, and we go back to this routine. I'm going to do reset. I'm going to do deploy, which should sort of lower the pin, which it does. I'm going to do store the pin, which should raise the pin, which it does. So all those options here on this LCD 12864 here, they all seem to be working okay. Now what I'm going to do now is actually plug in this. I'm going to plug in into pronto face over USB, because I can't work the servo off this LCD 12864. Well, not as far as I know, but I can work it off pronto face going over USB. So I'm going to see that that is like moving as I want. Like in pronto face I'm going to use M280 P1, which is a servo port that this servo is coming off, and S25. S25 is going to move it, or should move it near that threaded rod there. There we go. That's about as far as I can really go with that physically, so to speak, because that threaded rod is going to stop it. Might go a little bit more, but not much. And I'm changing that to M280 P1 and S180, which should bring it back. And this is what I'm going to term as a park position. It's a good position to be in when it's printing, so to speak. So that's, those movements are okay. Using front to face. Now what I do have a, like the start script I intend to put under my start G code, so to speak, actually on the SD card here. Now this might need a little bit tweaking, so to speak. I'm just going to select that off my SD card now. And the first thing it does there is do a home. That's like a security camera in the background there, so I can like remotely watch the prints if I want to, or need to, so to speak. Just a cheap security camera. So there's doing the home using a BL touch. Gets a big thumbs up, this BL touch. You might just see some of the reflections in this as a bulk of silica glass here. So it'll work on just about any surface. Now it's going left, so it's raised the nozzle to a height where it's just about scraping there's a piece of silicon rubber on there. Well, it's just on the inside of that, and it's going to be warming up the nozzle now, and the temperature is actually coming up on the nozzle. I'll try and show you that. Turn this LED off again. Let's turn this other one off. Can we see that? So 245 is the aim nozzle. That's my normal, well, ABS sort of temperature at the moment, and the temperature is increasing. I'll come back when that gets to about 240 odd. Well, probably a bit before. Well, the temperature's coming up to 240 now, and it's set to 245, and you might see some nozzle, some ooze, sorry. Yeah, so just now, after it actually reaches the temperature, it's 245 now, the arm should move across and wipe that off. Sorry, actually, no, it should ooze, it feeds out 10 millimeters of filament, and then it pauses a bit to allow that filament feed to ooze a bit more. Then it will retract 2 millimeters, then it will wipe that off. So it does sort of ooze a little bit after that 10 millimeters of feeding there. And after a few seconds or so, it should move across and actually wipe the nozzle. And I can see that moving, that filament in there. I don't know if you can. That shows that it is actually oozing a bit. Oops. I'll go up if I can get this tripod to work. Don't know how well we can see that. But that filament is actually moving a bit, even though it's actually not told to feed at the moment. And it's going into the tray. But after a few more seconds or so, there's a sort of withdraw, and then it's raising the nozzle, and now it's going to bring this arm forward here. And now it's going through, I'd ask it to go through like a movement routine, just to sort of, well, imagine it's printing in a way at the moment, because this is just test code. So in here, yep, it's got that reasonably well. It's got this bit of ooze out. That seemed to work very well. I do sometimes think that a little bit of a brush on here might also help. I don't know. This is still to a certain extent under development. Okay, but that seems to all work all right. Now I'm going to do this about maybe 10 times or at least to test this out, because the other day when I was using this system and I was using it off the jumper, there's a jumper that goes from VCC to 5 volts, it was unreliable. Sometimes it would trip, sometimes the arm would stop like moving at the wrong position and things like that. Sometimes it would work all right. So it was like borderline of the ampage. So that is why I've put a buck converter from 12 volts to 5 volts and plumbed that into the 5 volt input instead of having the VCC supplying 5 volts to the 5 volt input. I asked the buck converter to supply 5 volts to the 5 volt input. So here I'm going to try to show you, well, some diagrams of the ramps 1.4 and how I wire it up. So here's like one of the main diagrams in a way. Zoom in a little bit here, get a bit closer. So you can see the servo pins, and the input power is on the left hand side there. So we've got 5 amps and 11 amps, 12 volts basically going in. Notice that does suggest that you can go up to 35 volts going in. Whew, I don't know about doing that. But anyway, over here somewhere is the servo pins. Now normally, well, in my case I have been, well was, putting a jumper on 2 pins from VCC to 5 volts. So as far as I understand it anyway, VCC is like the power of the ramps from the ramps board itself, 5 volts, and that's connecting to 5 volts. So it's taking 5 volts from VCC into the 5 volt pin. And then that 5 volt pin is connected to all the middle pin row on the servo group, basically. So while that jumper is connected, it's taking power from the ramps board. Now if we unplug that and connect a 5 volt power supply to there, we can power the servos directly off that 5 volt power supply. And basically that's sort of what I'm doing with a buck converter. So here's a look at the ramps 1.4 PCB layout. Now this is like 2 images in one, so it's a bit awkward to see. But the green sort of circles over here on the bottom right are basically the servo group. Servo, I keep saying servo group of pins over on the right. And if you follow that blue middle line coming round, it goes under the red one there, and it goes to the middle pin over here, more near the left of that group of 3. Now normally I would have the jumper between that one and the one above it, so that's VCC to 5 volts. But if we put 5 volts on that middle pin there of those group of 3s, it's going to provide 5 volts to all the middle row of the servo pins down here. And basically that is exactly what I'm doing with the buck regulator that I'm using. Putting in 12 volts into the buck regulator, that's lowered down to 5 volts, and that is the pin from that, well, the connection from that is put on that middle pin of that group of 3 to provide 5 volts positive over to that middle row of the servo pins. So if we imagine that connection here, it's shown in red here, I'll highlight it, is going from that middle pin marked as 5V on the ramps board of that group of 3 over there, over to the full row of the servo pins, middle row, to provide 5 volts there. Now the ramps, in a way, can't really provide enough current to run servos reliably. That's my understanding, and that is why I have been adding this buck converter. So the connections are as shown here to basically got a red wire here going from the buck converter, in my case, any sort of 5 volt reliable supply basically, going to the middle pin marked 5V. That goes, it's not actually shown on the board, but I'm just highlighting that sort of goes underneath on a track and goes to the middle pins over there. And I've got the negative, in my case, I've got wired into the negative of the power supply up there, the 11 amp one in this case. Really, it doesn't matter where you put the negative, so long as it's got a good connection to a negative supply on the ramps. That's my understanding, but that's where I have mine. So it's like 5 volts is going negative, is going to that negative power input on the 11 amp plug, and the 5 volt positive is going to the center pin of that group of 3, and that's supplying 5 volts to all that row of servo pins. That's it really. And I'm hoping that will be a lot more reliable. But that, as you've seen there, that seems to work okay. I'm going to do about, say, 10-11 tests, doing exactly the same thing here I've just done. See if it looks reliable before I add this sort of code, G code, that tells it to move and move the head in certain positions, to my actual printing code. I'll come back after I've done about the 10 tests and I'll discuss any issues or anything. Well, if I see any issues and I can film them, I'll film them, you know. I try to be pretty honest about things. But that seemed to work alright. This has smooth edges on, so you can just pick it out, what have you. Okay, I've given it a few bits of tryouts and it seems to be going reliably as far as I can tell. Well, I have known it seem to go reliably before when it was on the jumper plug and then start going faulty, so I can't really guarantee the 100%. I have changed the code. One significant piece of code I've had to change almost is that after feeding, and I've known this happen when I've been doing things before, after feeding, even if the printer's been left, if you turn the printer back on, the first thing it does is retract that amount of feed you've just done. To me that's a bug. You know, it goes into reverse. So if you've fed it 100 millimeters, it sucks up, it tries to retract the filament 100 millimeters when the printer's getting turned on and such like, or starts up, I can't remember exactly what. And I noticed that on this, so I've put an extra bit of line that sort of resets the extrusion, basically. I've also delayed the time that it stops over here a bit, and I've asked for 4mm retraction because it was still oozing. Maybe not as bad, so to speak. It was doing reason. It's sort of one of these things that, well, I don't know. But one thing I've just noticed, I've just tried it now, and it did get this filament off. Only trouble was, well, this arm swings around here as you've seen, and then after it's warmed up and oozed out, well, it's actually feeds, but then it pauses about 10 seconds to get any ooze out, and then the arm swings a bit further to actually wipe the nozzle. But it was so quick that this got thrown off to the side of the printer, this bit of ooze here. I don't know if I'll do that again, but it unlikely. I think it's one of those things that sometimes it might do it and might not. See, we've got quite a bit of ooze on here. That's because it's just been stood over here. Really, what this printer might need is actually a better E3D version 6. This is a clone. This is one that's got like a piece of PTFE tubing in the throat, what's known as a throat. So it's not really the best hot end. It's just a cheap clone copy base. Well, cheap, whatever cheap is. So that's oozed out. Now it's pausing there to allow any ooze. So it's fed some, it's pausing to allow any ooze to go. Now it's retracted a bit and now it's swung that way. And when it did that before, it swung so fast that it actually threw the filament to one side. Now that has done a good job there, I think. There's a filament that's caught in this sort of tray thing, which, because it comes to the front, I can get out, and because of the curves in here, I can get out. I'm going to do that again. Now one problem, because I'm asking for 4mm retraction, is that means that it might not start layering plastic actually on the print for quite a bit. So skirts are almost paramount. Now what's to stop somebody sort of doing that anyway, doing a 4mm retraction before they start printing to stop any use? well, probably nothing. But I'm an experimenter, so it's just something I wanted to try and resolve an ooze issue. See, there's ooze there now, but that's because it's been stuck to the right for half a second and it's oozed. It's oozed. So I'm going to leave that on. Goes across, it feeds about 10 millimeters, pauses a bit, lets any ooze come out. So it's stopped, and then it will retract 4 millimeters. There it goes, and then it wipes it. See, there's still a bit on there. I don't know if you can see it, but I can. It's a small amount, but there's still a bit on it. I don't know what to say about this. I just don't know. I think it's a case of get a better quality hot end or something. If I want to stop this, I'm going to look up that. But the idea is reasonable. Maybe a bit of a, as I say, like a brush. This is a silicon piece of bacon silicon. If you see my other video about this, let's see what about that. Right, I'm going to finish off this video now. I'll just do it one more time, basically. Can I? No. Takes a bit to, right, so there it is forming. And it raises the nozzles. Now we'll do that in the cold position. Well, the first thing it does is actually make sure this arm is in its back position, but then it forms, raises this nozzle to the height where it will be just scraping the edge of the thing, brings the nozzle left into a position, brings this round into a position where it can be ready to wipe the nozzle, feeds some filament, pause a bit to let it ooze. Then it will wipe that, try and wipe that off just now, while it does some retraction. You see, that's almost like knocked that filament over there, and it's still on there. Oops, it might fall off. It's hard to show you this because you see that filament is still left hanging there. So it hasn't really removed that piece of filament. So I honestly don't know. I'm going to have to think about this. Now it is possible, you know, when I said it went down so fast it knocked it out through here to the side of my printer here. It is possible to slow the servos down, okay? It is possible to change the speed. I think that's more actually getting into the C code of Marlin. Not something I particularly want to do. I'm going to actually probably add this bit of code to a piece of actually printing stuff. Now I might want to actually do this twice. Once initially and once after the auto leveling, because while it's auto leveling it's oozing. Because the temperature is set and it's oozing. So I might want to do it twice before I even start the print. Okay. But I honestly don't know the sort of good and bad about it. Sometimes I think it works okay and sometimes maybe not quite so good as you just seen there.